Hi guys, I'm Sid. This is my latest creation, the Table Tombot. The Table Tombot has a tendency to find and push off objects off his table. At the same time, he doesn't want to fall off the table himself. So let's power him up and see him run. So first, we're going to put a 9-volt battery in the back to power all the accessories using a 5-volt regulator. There we go, so I can see that light go on. This might be a little inconvenient when putting in the battery. I'm planning to improve it in the future. Next, we need to put in another set of batteries to power up the computer inside. So I'll click the on button and just place it in. So now let's see it run. Center it, and now all I have to do is click this little button right here. So it's scanning and found an object. It's pushing it off the table, and it uses IR sensors to make sure it doesn't fall off the table. Scanning. Smoothing. So I found the bowl. Oh, missed it by a little. Finally, it found the object and it's going to push the last blow off the table. So now the table is his. Now let's off the robot. Once it comes forward, and it's off. So now let's see the mechanical design of the robot. So first, the shell. The shell is made of durable plastic. I used a wall TV cable concealer. You can get it at Home Depot for a couple of bucks. So I used some adult help for cutting it onto size and drilling holes for LEDs, nails, etc. Next is the chassis and the drive system. So you can see that I used 2 continuous rotation servos from Parallax on the robot, and 2 of them, and I used a free wheel in the front. It's not exactly a caster. I got it from an erector building kit. Put it together, it works. And then there's like a plate, like a support plate. It's actually a Tamiya universal plate. You can get it online from multiple sites. Then there's a switch, if you can see that closely. A switch, which is for onning and offing the robot. Then there's the battery compartment for holding the 9-volt battery for powering all the accessories. Then as we go up front, we see the erector beams that support and attach the 2 infrared sensors. They are the sensors that detect whether the robot is going to fall off the table or not. So they're like fall avoidance sensors. Then we have now as we go up top, we have the LED in a dome, which is actually a Lego piece. So it opens up on a Lego hinge. So it's actually supposed to just dramatize the lighting effect. Then as we move up over here, we have a regular 180-degree servo. It's currently not being used right now, but it can be used for using it as like a turret for sensors. And right over there, as we come back to this place, we can see a LED just faintly popping out. So this is supposed to be just like a bloater. Then there's an ultrasonic sensor, which is supposed to detect any objects on the table. So this is the sensor that finds the objects that the table Tombot wants to eliminate. So yeah. Now let's take a peek inside. So it's being attached by a couple rubber bands. So in here, as you can see, first there's a 9-volt battery case housing a battery that powers the computer itself. And in my case, the computer for me is an Arduino ADK, a Mega. But you don't have to specifically use that. You can use any Arduino, including an Arduino Uno, which is like the standard Arduino. So then there's a breadboard over here, which is the connecting source of all the accessories. On the end of it, there's a 5-volt regulator connected to the 9-volt battery. This is responsible for powering all the accessories: servos, continuous rotation servos, 2 IR sensors, ultrasonic, servo, switch. Everything is powered by this regulator right here and the breadboard. So the Arduino, the computer, and the breadboard may share separate power sources, but they both, most importantly, they both have to share the same ground. But all the sensors and continuous rotation servos and all the servos, their power source goes to the breadboard, but their control, like their signal, goes to the Arduino itself. So that's basically the inside, and that is the mechanical design. To learn about the circuit schematic and the program of the Table Tombot, visit my website.